Hi, math students. I hope you're all well. And today we're going to be learning about transformations. So transformation is a way of changing the size, order, position of a shape. And today we're going to focus on reflections. So just a few images showing reflections. We can see reflections in nature. So we can see an eagle reflecting in water. We can see some art drawings, so a bird being reflected. And the types of examples which you will see is a reflection of shapes into an axis. Now, for any reflection to occur, there has to be a reflection line or a line of symmetry or a mirror line. So that is required for the reflection. Now, to make sense of this, I'm going to go onto this slide, and it says draw the mirror line y equals 1. So you need to be very good at drawing your mirror lines or your lines of symmetry. Now, the line y equals 1. So what we're looking for is for a line where at every point on that line, the y coordinate will always be 1. So if we have a look at our x-axis here, sorry, apologies. If we have a look at the y-axis here, what we have, if we think about this coordinate here, we will get, and I'm just going to draw on this, it will be easier. There we go. So if we think about this coordinate here, this coordinate is -1, 1. If we think about this coordinate here, we have -2, 1. If we think about this coordinate here, we have -3, 1. If we think about this coordinate here, we have -4, 1. And likewise here, if we go on this point here, what we'll have is 6, 1. Or this point here, we'll have 7, 1. So our line y equals 1 will be a straight line across here. And if I just clear the drawings, this is what the line will look like. At any point on this line, your y coordinate will always be 1. Your x coordinate will change, but your y coordinate will not change. So this is the line y equals 1. Now, let's try another one then. So the line x equals 2. So now, again, the line x equals 2 will be across this line here. So if I just draw it on, as you can see, again, on this line, your x coordinate will always be 2. So if I pick any point, if I pick this point here, our x coordinate is going to be 2. So this is the point 2, 3. Oops, sorry, there we go. If I pick another coordinate, say if I pick this point here, that's still going to be 2 minus 2. If I pick this point here, our x coordinate is still going to be 2, our y coordinate is going to be -7. So this is the line x equals 2. And if you ever get confused, if you weren't unsure, just think about the coordinates or draw another line on the opposite axis. So think about this coordinate here. If we were to draw a straight line, and I think it'd be better off using, if we were to draw a straight line here, will the x coordinates always be 2? So at, let's say, this point here, my x coordinate is going to be -6, my y coordinate is going to be 2. So x is not equal to 2 at this point. Likewise, at this point here, my x coordinate is going to be 6, my y coordinate is going to be 2. So this is the line y equals 2, this is the line x equals 2. So if I just clear my drawings, and we can try another example. So the line y equals -3. Again, let's think about -3. -3 is either over here on the x-axis or -3 on the y-axis. So are we going to draw a vertical line or a horizontal line? Well, at this point here, if we were to draw a vertical line, that would look something like this. And if we were to draw a horizontal line, I'll just draw it with yellow. And then let's pick some points. I'll use a different color pen. Right, so on this line here, this point, we're going to have -3, 2. At this point, we're going to have -3, 4. So your y coordinates is changing, it's not constant, it's not always equal to -3. Whereas on the yellow line, at this point, our x coordinate is going to be 6, our y coordinate is -3. At this point here, our x coordinate is going to be 4, our y coordinate is still going to be -3. Likewise, at this point here, or at this point, at any point on this yellow line, y will always be equal to -3. So if you ever get confused, draw a line across the x-axis and the y-axis, and then pick points to see whether the value you're given is constant along that line. Okay, and moving on. So that's the line y equals -3. And we've got one more, the line x equals 0. Well, the line x equals 0 is just the y-axis. So sometimes you might be given a question where it says reflect a shape in the line x equals 0. The line x equals 0 is the y-axis, because at all points on the y-axis, x will always be equal to 0. So at this point here, x is equal to 0. At this point here, x is equal to 0. At this point here, x is equal to 0, and so on. So the line x equals 0 is simply the y-axis. All right, and moving on. So there is another mirror line. So this is the line y equals x, and this one can be a little bit tricky. But let's think about some coordinates. So if x is equal to 0, y has to be equal to that coordinate. So y is also going to be equal to 0. Likewise here, if x is equal to 1, y will also have to be equal to 1. If x is equal to 2, y will have to be equal to 2. If x is equal to -4, y will be equal to -4. And if x is equal to 8, y will be equal to 8 as well. Right, this is the line y equals x. So whatever your x coordinate is, that will also be your y coordinate, or vice versa. Now, if we were to plot some of these points, what we have is this coordinate here, 1, 1. Then we can plot 2, 2. Then we can plot -4, -4. So going across and then coming down, that's going to give us the coordinates of -4, -4. And then I believe we have, yes, so we've got 8, 8 up here. So what we can do is, if we were to draw a line that goes through all of these points, this is what a line will look like. And again, what we can see is at each point on the line, the x value, or the x coordinate and the y coordinate, are the same. So if we pick this point here, x is -2, y is -2. If we pick this point here, or this coordinate here, x is 3, y is 3. If we pick this coordinate here, x is 4, y is 4, and so on. So this diagonal line is the line y is equal to x. And again, if you get confused in an exam and you weren't unsure how to draw your mirror lines, just start plotting coordinates and then draw a line through that coordinate, and hopefully you should get the correct mirror line. Right, and moving on. So let's try and write the equations of these lines. So this line here, again, what we can do is look what is constant along the line, or what coordinate is constant along the line. So if I pick a different color pen, right, at this point, what we have is 1, 2. At this point, what we have again is the coordinates 1, 5. At this point, we have the coordinate 1, minus 2. At every point on this line, your x coordinate is always going to be 1. Therefore, the line is, or the equation of this line is x is equal to 1, because x is always 1 at any point on this line. So the equation of this line is x is equal to 1. Let's try another one. I'm just going to erase this. So again, if you wanted to pick some points on this line here, so what we have is 2, 3. What we have here, or the coordinate here, is going to be 5, 3. The coordinate here is going to be minus 5, 3. So the equation of this line, well, your y coordinate is always constant, so y is equal to 3. At any point on this line, y will always be equal to 3. And if I just clear the drawings, and we can do one more example. So with this one, y is going to be equal to minus 7, because if you pick any point on this line, y will always be minus 7. And one last example here, if I pick any point on this line, x will always be minus 7. So this is the line for x equals minus 7, and maybe I'll just write that to avoid any confusion. So here, y equals minus 7. Over here, this is the line for x equals minus 7. Remember, at this point, x is minus 7. At this point, x is minus 7. At this point, x is minus 7. At any point on this line, x will always be minus 7. All right, so let's move on to reflections then. When we reflect a shape, so what we have is reflect the shape in the x-axis. So this is the x-axis here. So this is our mirror line. So we need to draw this shape, but in a symmetrical way on this side of the x-axis. So what we need to do is pick corners, and I will start with this corner here. So this corner is 1, 2 squares away from the x-axis. So we need to go the same distance across over here. So the distance is exactly the same. Therefore, this point and this point are split evenly along the x-axis. Then we can pick this point over here. So again, we are 1, 2 points away from the x-axis. So we need to be 1, 2 points away from the x-axis here. And then we can go to our final point or final coordinate or corner. This corner is 1, 2, 3, 4, 5 squares away from the x-axis. So we need to go down 1, 2, 3, 4, 5 squares along the y-axis, I suppose, because we're going down. So now what we need to do is join up the points. So we can draw a straight line. You would have to do this with a ruler. Join the corners, and what you have is this shape here, and we can call it shape B. So this shape has been reflected into the x-axis, and this is what it will look like. Let's try another example. So here it says reflect shape A in the line x equals minus 1. So now we need to draw our line of symmetry, or we need to draw our mirror line. Now to draw the line x equals 1, we did this previously, so this is going to look like this. This is the line x equals 1. Because at any point on this line, x is equal to 1. So this is our mirror line here. Sorry, it says x is equal to minus 1. So I'm just going to change that. X is equal to minus 1. would be over here. And again, in an exam, you will have to use a ruler. Now, to reflect our shape, we need to pick the corners. So let's start with this corner here. And maybe I should use a different color pen. Use orange this time. So, well, there we go. So let's pick this corner here. And how many squares are we away from the line of symmetry? So that's going to be 1, 2, 3, 4, 5. So we need to go 5 across. 1, 2, 3, 4, 5. Now, likewise with this corner, we are 1, 2, 3, 4, 5, 6, 7 away. So we need to go 7 across. So that's going to be 1, 2, 3, 4, 5, 6, 7. And then this coordinate here, or this corner here, is 1, 2, 3, 4, 5 across. So we need to go 5 across again. 1, 2, 3, 4, 5. And I suppose you wouldn't need to count if you've already done this corner here, because they should align together when you reflect the shape. So this is what we've ended up with. These are our corners. So we need to join them up using a line. So join up your corners with a ruler, of course, and this is what our shape will look like reflected in the line x equals -1. Okay, let's try another example. Right, so here what we've been given is reflect the shape A in the line y equals -x. So the line y equals -x, this is slightly tricky. How would we draw this line? Well, we need to think about coordinates again. So y equals -x. So y equals -x. I just change. Let's think about it then. So when y is equal to 1, x will be equal to -1. When y is equal to 2, x is going to be equal to -2. When y is equal to 3, x is going to be equal to -3. And as coordinates, seeing as x always comes first, this would be -3, 3. This would be -2, 2, this will be -1, 1, and so on. And if we were to plot these points, so -1, 1 would be here, -2, 2 would be here, -3, 3 would be here, and so on. So what we're going to end up with is a diagonal line that will look something like this. So this is the line y equals -x. And if I clear the drawings, when we reflect a shape diagonally, we need to count the squares diagonally as well. So if we start with the corners again, and I'm going to pick this corner here, and I'm going to count 1, 2 across diagonally. So I need to go down 1, 2, and I'll end up at this point here. Likewise with this corner, we're going to go 1, 2, 2.5. So that's going to be 1/2, 1, 2. And the corner is going to be here. And then lastly, we're going 1, 2, 3, 3.5 across. So we need to go 1/2, 1, 2, 3. And this is where we will end up. Again, use a ruler to make sure you avoid any mistakes. Once you've drawn your points or your corners, you can join them up using a ruler. And this is what our reflected shape will look like. And shape A has been reflected in the line y equals -x to look something like this. All right, moving on. And if I just clear the drawings. So it says reflect the shape in the line y, in the line with the equation y equals 4. So again, we need to draw this line, and the line y equals 4 will be drawn here. Remember, at any point on this line, y will always be 4. So this is our mirror line. So this is the line y equals 4. And now to reflect the shape, what we need to do is pick the corners. So this corner is 1, 2 squares away from our mirror line. So we need to go 1, 2 squares away. Then pick your next corner. Make sure you draw on the corner so you know you've dealt with that corner. And again, this one is 1, 2 away. So we need to go 1, 2 down. Then you can pick this corner here. That's going to be 1, 2, 3. So we need to go down 1, 2, 3. And then with this corner, it's again going to be 1, 2, 3. So we need to go down 1, 2, 3. With this corner, it's going to be 1, 2, 3, 4. So we need to go down 1, 2, 3, 4. And then we have this corner. Again, the distance is 1, 2, 3, 4. So we need to go down 1, 2, 3, 4. And then we have this corner, which is going to be 1, 2, 3. So we go down 1, 2, 3. And then lastly, this corner here, which is 1, 2, 3. So we need to go down 1, 2, 3. And then we just need to join the points up. And our shape will look something like this. Again, use a ruler when you do this, it's very important. And this is what our shape will look like reflected in the line y equals x. Let's try one more example. And if I just clear the drawings. Okay, so over here it says, reflect the shape in the line with the equation y equals minus x. So the line y equals minus x will look like this, as we discussed previously. And now we need to reflect the shape diagonally. So again, let's pick the corners. So I'll start with this corner here. This is 1 square away from our mirror line, so we need to go 1 square across. We can then pick this one, which is 1, 2, 2.5. So half, 1, 2. We're going to end up over here. And don't forget to draw over it so you know you've dealt with it. Then we have this corner here. So we are 1, 2, 3, 4 squares to our mirror line. So we need to go 1, 2, 3, 4 squares to our mirror line. And then we have our final point, which will end up here. I suppose you can sometimes see it visually, but let's just count to see if that's correct. So that's going to be 1, 2, and we need to go 1, 2 across as well. And then join the points up using a ruler, and your shape will look something like this. And you know that's correct because it looks like the shape you started with, but its orientation is just different now. All right. Now, last thing to cover, so if I clear the drawings, sometimes you'll be asked to describe transformations. Now, what this looks like is a reflection. Now, we need to explain that this is a reflection, and we need to explain what the line of reflection is. Now, if we pick 2 corners, so you can pick any 2 corners from each shape. So I'm going to pick this corner here and this corner here, and count the distance between the corners. So the distance between them is 2 squares. So if we split or if we half the distance between them, we would get a line that would look like this. So this is our line of reflection. This shape B, is exactly 1 square away. Shape A is exactly 1 square away at these corners. Likewise here, if we pick different corners, so this corner is 2 squares away from our line of reflection, and this corner is also 2 squares away. So this is the correct line of reflection, and we just need to be able to explain what line this is. So this is the line y equals 5. because at any point on this line, I should have drawn it with a straight line. You should draw it with a ruler. But at any point on this line, y will always be 5. Your x coordinates will change, but your y coordinate will be fine. So this would be a 2-mark question, and what you need to write is the transformation is a reflection in the line y equals 5. And you would get 2 marks for this. 1 mark for describing the type of transformation. So that's the reflection. And the second mark is describing which line the shape has been reflected in. Right, moving on. So if I just clear the drawings to our final example of the day. What we have here is describe a single transformation from shape A to shape B. Now, again, let's count the distance between 2 corners. So I'm going to pick this corner here and this corner here. So we've got 1, 2, 3, 4, 5, 6 squares. So halfway between 6 is going to be 3. So we've got 1, 2, 3 here. So my mirror line is going to be at this point here. And if I just draw it, this is what our mirror line is going to look like. And again, if we pick the other corners, we can see they're exactly the same distance away from the mirror line. So if I was to pick, say, this corner and this corner is 1, 2, 3 away. This corner is also 1, 2, 3 away. Likewise here, we are 1, 2, 3, 4 squares away. The other corner, or the corresponding corner, is also going to be 4 squares away. So that's 1, 2, 3, 4, which is over here. So our mirror line is correct, and this mirror line is going to be the line y equals 1. Again, we should be able to see that this is a reflection. So our answer is going to be describing the transformation. Our answer is going to be reflection in the line y equals 1. Right, I hope you found this useful, and I look forward to seeing you again. Thank you. Bye.